Hi everyone, let's continue. Level curves of a function z equals f of xy. Definition: let f of xy be a function and let c be a constant. The set of all xy points on the xy plane for which f of xy equals c is called a level curve of f, and we call c the corresponding level. A collection of level sets drawn together in the same picture is called a contour curve or contour map. If you're ever gone hiking, you probably know what a contour plot is. So let's look at the following example. Let x represent the longitude and let y represent the latitude. Let f of xy represent altitude, so elevation at the coordinate xy. Then the contour plot for the elevation function z equals f of xy is simply a contour map, like the type you use to hike. The curves in the picture represent the path you can take to stay at a fixed elevation. So if, for example, here, this means we have 4,800 feet along that line, right? So along this line, we have the same height here. So if you want to go down to the river, so you want to go to like perpendicular to in the direction perpendicular to those level curves, right? And this line represents the height is 5,200 feet. Okay? And let's continue. So for each function, let's draw the level curves. Okay, so how do we do it? Well, this is like the z, right? We consider z is like a constant c. Okay, and we want to think about, okay, what are the possible values for c? Can c be negative? No, c cannot be negative, right? Because x squared be greater equal to 0, y squared is greater equal to 0, so c cannot be negative. So we can think about, okay, so c can be negative in this case. So what happens if c is 0? Well, when c is 0, we have x squared plus y squared equals 0. This is just the points, the origin, right? And how about when c equals 1? Then we have x squared plus y squared equals to 1. This is a circle with radius 1, right? And what happened? Let's draw one more. What happened if c equals 2, then x squared plus y squared? Oh, let's use 4. Okay, let's use 4. Then we have x squared plus y squared equals to 4. This is a circle with radius 2. So far, so good, everybody. So the contour curve look like this. Okay, and let's continue. F of xy equals y minus x squared minus 2. So here, we consider z is like a constant c. So y minus x squared minus 2 equals c. Well, you can see the degree of y is 1, the degree of x is 2, so we can consider y is like a function of x. Then we move the x squared and the 2 on the left. And let's see what happened. So if c equals to 0, then we have y equals x squared plus 2. Well, this is a parabola opened up, and it passed through the point 0, 2, right? And it goes like this. Let me draw it better. Okay, and what happened when c equals to, let's say, 2? Well, then we have y squared plus, y equals x squared plus 4. So it passed through 4. So like this. And now you can imagine for other z values, let's say z is -2, then we just get y equals x squared, right? So we can see it's a lot of parabola. Oh, I didn't draw very nicely, but anyway, you know, they're all parabola. Okay. So we pick some values of the c. Then we can draw different level curves. Okay. Let's continue. Functions of the form w equals f of x, y, z. So functions with 3 input variables are of the form w equals f of x, y, z. The domain of such a function is the set of all possible input points x, y, z, and it is therefore a region in a space. The graph of a function f of x, y, z is the set of all order quadruples x, y, z, w, such that w equals f of x, y, z. And it is therefore a 4-dimensional graph, so it's a hyper surface, which we can draw in space. In space, we can only draw like 3-dimensional things, right? And this guy is actually a 4-dimensional graph. However, the level sets of the function f of x, y, z are of the form f of x, y, z equals c, where c is a constant in general. These level sets are surface in the space, so we call them the level surface of the function f of x, y, z. Okay? So even though this function this guy is in R4, so we cannot really draw it, but the level set, okay, the level set is actually a surface in R3, then we're able to draw it. Okay, so level surface, this is in R3, then we can draw it. Let's look at the following example. Describe the level set of f of x, y, z equals x squared plus y squared plus z squared. Sketch them for f equals 0, 1, and 2. Alright, so we have x, y, z. If f of 0, then what do we get? We have x squared plus y squared plus z squared equals 0. Well, this is the same as saying all of them are 0. So we get the points, the origin. Right? This is the origin. And now, what happens when f equals 1? Then we have x squared plus y squared plus z squared equals 1. This is a sphere with radius 1. So we have 1, 1. So let's draw it. Okay, it looks like that. It's a sphere with radius 1. And what happened if f equals 2? Then we have x squared, y squared, z squared equals 2. Well, this is the sphere with radius square root of 2. Square root of 2 is 1.414, so a little bit bigger than 1. So when we draw it, let's see. So you can see it's a bigger sphere. Can you imagine, everybody? I'm sure you can draw the better picture than I do. Okay, let's continue. Describe the level set of... Oh, I missed an F there. F of xy equals x squared plus y squared, and sketch them for f equals 0, 1, 2. Let's see here. Okay, so let's draw the x, y, z axis. So, if f is 0, then we have x squared plus y squared equals 0. Oh, that means x equals y equals 0, but z is free. Okay, z is free. What is this guy? This is actually the line that x and y is 0, and so 0, 0, z. This is the z axis. Can you imagine, everybody? And next, when f equals 1, then we have x squared plus y squared equals 1. Well, this is the circle on the xy plane, but if we put it in the space, it's a cylinder. Can you imagine, everybody? Alright, how about when f equals 2? Well, x squared plus y squared equals 2. Then we have, this is like square root of 2, square root of 2. Then we have a bigger circle on the xy plane. So we will get a larger cylinder. Can you imagine, everybody? Okay, so it's the vertical line and then a different size of cylinder, circular cylinder there. Alright, let's continue. Let f of x, y, z equals x squared plus y squared minus z squared. Consider the following list of level sets. Okay, match each level set in the list with its corresponding graph below. Okay, let's see. If f is minus 1, x squared plus y squared minus z squared equals minus 1. Okay, remember, if we want to decide whether it's hyperbola 1 sheet or 2 sheets, we need to make sure the right hand side, the 1, is positive. So let's multiply by minus 1, and then we put the positive coefficient term on the left, and then we have this guy. Okay, so here, if you can still remember, we have one term that's positive and 2 terms with negative coefficients. Then what is that? This is hyperboloid of 2 sheets. So hyperboloid of 2 sheets. So 2 sheets right here. Okay. So this is correspond to f equals minus 1. Let me see whether I can move this to that side, because I don't want you to get confused. Let me see whether I can move it. Yes, I can move it. So when I write a note, I didn't know which one is which. So let me move it here. Okay, there's a f here. Let me see whether I can erase it. Okay, I should not draw it first. Okay, let's see. I'm erasing it. Okay. So this corresponds to f equals minus 1. And when f equals 0, what do you say? When f equals 0, wow, we will get a cone, right? So if f is 0, then x squared plus y squared minus z squared equal to 0. Then we get an elliptic cone. Okay? And this is the picture of the elliptic cone. The right hand side, you can see, is not a number, is 0. And last, when f equals 1, so when f equals 1, then we have x squared plus y squared minus z squared equals 1. So we have 2 terms that are positive coefficients, 1 term with negative coefficients. That is hyperboloid of 1 sheet. So far so good, everybody? Okay. And this is sessions 12.2. Alright, so if you have questions, feel free to print screen and ask me in class or in office hours or email me. Have a nice day. Bye.